Hello all and welcome back to our session on converting NFA into minimized DFA. In previous session, we had seen how to convert a regular expression to NFA and then from NFA to DFA and from DFA to minimized DFA. We had seen some rules on how to convert these regular expressions into minimized DFA. In today's session, we will continue with where we had left in previous session with a question and then continue with another example to understand how these finite automatas are created from the given regular expressions. So here was the question, that is construct finite automata for r is equal to 1 1 plus 1 0 star. So we will start with converting the regular expression for 1 1 to NFA, 1 0 to NFA, the union of these two regular expressions, and then finally adding the star closure to this NFA for 1 1 plus 1 0. Now in the next step, that is step number 2, for converting NFA to DFA, what we will be performing is finding the epsilon closures for x. Now x is nothing but we will be starting with state number 0 for our that is our start state, and go on finding the epsilon closures from this state and then find the transitions from each state over the first input symbol, that is 0, and the second input symbol, that is 1. Then considering the distinct values appearing, the sets appearing in transitions over 0 and 1, we will take them as the next values of x. Now let us see what is the epsilon closure of 0. So we have epsilon closure of 0, always we will have the state itself as the first epsilon closure and then the transitions that occur from that state over epsilon. So from 0 we have 9, we have 1, we have 2, we have 5. So let us see, we have 0, 1, 2, 5 and 9. Now from this, the transitions over 0 are empty, that is there are no transitions over 0 from any of these states that is appearing as the epsilon closure of x. Now over 1 we do have two transitions, that is from 2 over 3 and from 5 over 6. So we have empty set and 3 comma 6. Now we will always consider the set of states before empty sets. So we will consider the next x value as 3 comma 6. The epsilon closure for 3 comma 6 will have 3 and 6 itself. The transitions from 3 and 6 over 0, we have one transition, that is 7, that from 6, and another and for 1 we will have 4. Now we will check or take the next x value as 7. So here we will have the epsilon closure of 7 as 1, 2, 5, 7, 8 and 9. The transitions over 0 are empty again and transition over 1 is 3 comma 6. The next distinct or unique value for x will be 4. The epsilon closure for 4 will be 1, 2, 4, 5, 8, 9. So here we have 1, 2, 4 and 5, 8, 9. The transitions from y over 0 will be empty set and for 1 it will be 3 comma 6. Now we are not left with any other distinct values that can appear in x. So we will finally take the empty set as our next value for x. The epsilon closure for empty set will be empty. The transitions over 0 and 1 will remain empty. Now we will convert this into DFA. So we will rename our states as A, B, C, D and E. Now wherever 9, that is our final state, is appearing in the epsilon closure will be marked as final states, and out of this A will be our start state. So let us see how this DFA is going to look like. So here we have A, C, D as our final states. So from A we will transit to E and B. From B we are going to C and D. From C we are going to E and B. Then next, that is E and B, and finally E and E. E, B, C, D, E, B, E, B and E, E. Now as we can observe here, do we have any common transitions? So we can easily see that EB, EB and EB are the common transitions that are appearing in our DFA. So we can merge these three states as X, as they all are having the same transitions. That was our one rule, and another rule was they all should be either final or they all should be non-final. So as it is clearly visible that A, C and D are final states, we can easily merge these three states and make it X. So let us see the next step of converting it into minimized DFA. So we are left with Y or X, whatever the naming conventions you are comfortable with. So we will be left with EB, YY and EE. Now there is no more same transitions appearing in our state transition diagram. So we will finally have the converted minimized DFA, and we are left with three states, out of which Y is our start state and as well as final state. So we will have a start state. Okay, then we have B and we have E. So from Y we are going to E over over 0 and to B over 1. Then we have a B to Y on 0 and 1, and finally a self loop over 0 and 1 in E state. So here as we can see, E is acting like our kind of dead state. We have seen the concept of dead state in previous sessions. So here this is how we will be converting our given NFA into minimized DFA. A given regular expression into minimized DFA. Let us consider another example. So we have to construct a finite automata that for R is equal to 0 plus 1 star, 0, 0 plus 1, 1 and convert it to minimized DFA. So first step will be converting our regular expression to NFA. So we first have 0 NFA, 1 NFA and plus with a star closure. Then we have the NFA of 0, 0 and NFA of 1, 1 at union. NFA is visible, and connect these two NFAs with a dot operator. So we are having total 15 states from 0 to 14. Now let us check the next step, that is converting our NFA to DFA. So for that, as we know that we have to find the epsilon closures. So we will start with 0 and we will have the epsilon closure as follows, that is 0, 1, 2, 4. Then we will have 7, 8, 11. Okay. Now we will check the transitions over 0 from Y. So we have 3, 9 and over 1 we have 5, 12. The next value for X will be the distinct values. Again, I'll repeat myself, will be the distinct values appearing in transition over 0 and 1 from Y. Okay, so next value will be 3, 9. So for the epsilon closure of 3, 9, the values will be 1, 2, 3, 4, 6, 7, 8, 9 and 11. The transitions from Y over 0 are 3, 9, 10 and 5, 12 for 1. The next distinct value is 5, 9. Sorry, it's 5, 12. Okay. It's a misprint. So this is 5, 12. The epsilon closure for 5, 12 will be 1, 2, 4, 5, 6, 7, 8, 11 and 12. The transitions over 0 will be 3, 9 and transition over 1 will be 5, 12 and 13. Next is the next distinct value is 3, 9 and 10. The epsilon closure for 3, 9, 10 will be a little bit huge as it involves 3 set of states. So here it will be 1, 2, 3, 4, 6, 7, 8, 9, 10, 11 and 14. Okay, and transitions over 0 are 3, 9, 10 and transitions over 1 are 5 and 12. The next distinct value we are left with is 5, 12, 13. So again the epsilon closure will be almost all the sets except all the states except 3. Okay, and we will have the transition over 0 as 3, 9 and transition over 1 will be 5, 12 and 13. Now we know that we have to rename our states as A, B, C, D and E, and wherever the final state is appearing in our epsilon closure, we will mark them with as final states. Okay, so we have D and E as our final states. So from here we will start with A going to B and C. Next we will be going to D and C. Next is B and E. Then we will be going to D and C, and finally B and E, right? So this is how we will be converting our NFA to DFA. That is what we will be seeing in the next slide. So here we have BC, DC, BE, DC and BE. So as we can clearly see that no common transitions are present, and even if there are two transitions which are common, that is BE, BE and DC, DC, but both have different, that is one is a final and another is a non-final state. So we cannot apply the merging step here, as no states are either final and no states are either non-final. So now we are left with 5 states. So we will start with A, that is our start state. We have B, C, D and E as our final state, and also D will be our final state. So from A we are going to B over 0 and to C over 1. From B I am going to D over 0 and C over 1. Next from C I am going to B back on 0. Okay, and from C I go to E on 1. From D I have a self loop over 0 and I go to C over 1. From E I go to B, I have a self loop over 1 and go to B over 0. Okay, so this is what the NFAs and converting a regular expression to NFA, then from NFA to DFA, and finally DFA to minimized DFA will be looking like. So we have altogether 3 steps. So from regular expression to NFA, NFA to DFA, DFA to minimized DFA, and finally the transition diagram. In case you have any doubts or any queries regarding today's session, you can leave it in our comment section. We can get it resolved in our next session. So see you then.